Hey, it's Neil from Gradesavers, and today we're doing question number 45 from section 7.2. The question reads, what is the definite integral from 0 to 1 of e root x dx? And they would like for us to make an appropriate substitution before we begin integration by parts. So let's begin. In order to do substitution, we will first select our u, and we will let u equal to root x. This means that dx will be equal to du over the derivative of root x, which is simply 1 over 2 root x. And if you're having trouble with this derivative, you may rewrite this as x to the half, which means the derivative d dx is simply half x to the negative half, which means it will be 1 over 2, and if we bring this x to the denominator, it will become root x in the denominator. Alright, moving on. In order to simplify this, the 2 root x comes up beside the du, so it becomes 2 root x du. And we notice that we have a root x here, which is equivalent to our u. So it becomes 2u du. Since we also have bounds on this question, we should convert these variables, or these numbers 0 to 1, which are in terms of x, into bounds that are in terms of u. So we can use this equation to do that conversion. When x is equal to 0, u is equal to root of x, so square root of 0 is also equal to 0. When x is equal to 1, u is equal to square root of 1, which means u is equal to 1. In this case, the bounds ended up staying the same from 0 to 1, but this is not always the case, so make sure you do this conversion. So the integral we end up with when we do our substitution is e to the root x becomes simply e to the u, because root x is replaced with u, and dx is replaced with 2u du. And this is where we need to use integration by parts. So for the sake of clarity, we're going to use u1 and v1 since we already had a u variable on its own here. So u1 we'll select to be 2u, and dv1 is everything else that remains, which in this case is e to the u du. In order for us to find du1, we simply take the derivative of this, which is 2, and stick on a du. And in order for us to find v1, we take the antiderivative of eu, or the integral of e to the u du, and we get e to the power of u. And now let's recombine this using our formula that we have up here. So this simply becomes, and just for clarity, this becomes u times v, or u1 times v1, evaluated from 0 to 1, minus the integral from 0 to 1 of v du1. And now we need to simplify this by first figuring out what this integral is equivalent to. You may begin evaluating this here right away if you'd like, but I like to leave my evaluation till the last line. So in order for us to evaluate this, I'm going to slightly rewrite this so the constant is in front. So it becomes 2 times e to the u du. And easily we can see the antiderivative of this is simply 2 times e to the u, evaluated from 0 to 1. And now we can begin plugging in our numbers. So we first plug in our 1, so it becomes 2 times 1 e to the power of 1, subtract, and we plug in our 0, 2 times 0 e to the power of 0, so we're done evaluating this one, minus, and we're going to use brackets because this, whatever we evaluate this integral to be, is in brackets because of the subtraction sign here. So this will become 2 times e to the 1 minus 2 times e to the 0. Alright, looking at this, we see that this entire term will become 0, and we can simplify to the next line. 2 times 1 is simply 2 to the power of, or 2 times 1 is 2 times e to the power of 1 is simply e. This term is 0, so we don't include it, and we're going to open up our brackets here as well. So 2 times e to the 1 is simply 2e, but because of this negative sign, it's negative 2e, and 2 times e to the 0, well, e to the 0 is equal to 1, so negative 2 times e to the 0 is negative 2, times this negative is positive 2. And it turns out this negative 2, or sorry, this 2e and this 2e here, cancel out, so we're left with simply 2. And that's it for the final answer. Hey, thanks for watching. Grab the PDF from below, and remember the best way to study is to join the Gradesavers review sessions.